So today we're going to cover Chapter 2, Section 6, and we're going to learn how to combine functions and find composite functions. So when we want to combine functions, they're going to show like two different functions, f plus g of x, and essentially when you're adding and subtracting, we're just going to be combining like terms. So when we subtract, we'll be, again, subtracting, but just remember you're going to need to distribute a subtraction sign. And then we'll just multiply. We may have to FOIL some things, but again, we'll just be using distributive property. And then the same thing for division. Notice the g of x not equal to 0 here at the bottom. This is just indicating that we can't have a 0 in the denominator because it would be undefined. So let's do our first example. It has f plus g of x. So the original functions are up at the top. So what we're going to be doing here is taking the f of x function, which is 2x plus 1, and adding it to the g of x function. So all we're doing here is combining like terms. We're not solving anything. So I don't have any x squared terms to combine, but I do have some x terms. So 2x plus 2x is 4x. And then notice the 1 minus 1, and it's gone. So my final answer is just x squared plus 4x. Now, they want me to take this combined function on number 2 and plug in a 2. So if I hadn't already combined the f of x function and the g of x function, then I would have had to do what I just did in number 1. But since I've already got it combined, I'm going to take that answer, the x squared plus 4x, and now I'm going to substitute 2 in here for x and then simplify. And then the final answer of f plus g, when you plug in 2 for x, equals 12. Then for number 3, we're going to do the same thing. We're just going to combine like terms, but what you have to do is be careful here. Because really what this means is f of x function minus the g of x function. So I'm going to take f of x, which is 2x plus 1, and I'm subtracting the g of x, which is the x squared plus 2x minus 1. I need to distribute this subtraction sign. So this becomes 2x plus 1 minus x squared minus 2x plus 1. Now I can go back and combine my like terms. So I don't have anything to combine with the x squared. I have a 2x minus 2x, and that's gone. And then I have 1 plus 1, and I get 2. So that's my final combined subtracted functions. Now I'm going to take that answer I just got from number 3, and I'm going to use it for number 4. Because again, what I'm looking to do is f of x minus g of x, but I already did it, and I got negative x squared plus 2, and now I'm going to plug in 2 for my x. So when I plug in 2, be very careful with that negative sign. This becomes 2 squared is 4, and then negative 4 plus 2 is negative 2. So the f of x function minus the g of x function, when I replace x with a 2, and my answer is negative 2. So multiplication, again, this means f of x times the g of x function. So my f of x function is x squared, and I need to multiply that to the g of x function. So all I'm doing is distributive property. X squared times x gives me x cubed, and x squared times 3 gives me negative 3x squared. And I'm done. Now, they're asking me to take the f of x function and the g of x function, and after I multiplied them, it wants me to substitute in a 4. So I'm going to take the answer I just got in number 5, the x cubed minus 3x squared, and now I'm going to replace x with a 4. So 4 to the third, and then 3 times 4 squared. Again, I'm following PEMDAS. 3 cubed is 64. I need to do the exponent first. and then I multiply. And I get 48, subtract, and the final answer here is going to be 16. So for number 7, what this means is I'm really just doing f of x divided by the g of x. So my f of x function is the square root of x. My g of x function is 4 minus x squared under the radical. I'm done. I don't need to simplify anything here. It just asks me to plug it in. So just remember this is a fraction bar here. Now, it's also asking us to find the combined function, which I just did, and then the domain. So this is what you just did on the test. So remember, when it's a radical in the numerator, we need to set that to be greater than 0. So x is greater than or equal to 0. And then for the denominator, only greater than 0, because it can't equal 0. So once I solve this, add x squared, then I get 4 is greater than x squared. But remember, we need to get the test point, so we're going to solve this as if it's an equal sign, and we get plus and minus 2. So this is what's going on my number line right now. So I have -2, 0, and 2. So here we can see that I've got an open circle here, once I'm done. But I got to do my x check thing first. Let me do this one first. So I need to do -2, +2. I'm going to test 0. Let me do a open circle here. So then I'm going to plug in 4 minus 0 squared greater than 0. 4 is greater than 0. So check x, x. So this tells me that right here is going to be combined. And then from the numerator, I had everything greater than or equal to 0. But remember, the domain is a combination. It's where the intersection is. So the only thing that's in common is right here. So my domain is only going to be the green, and it's going to be from 0 to 2. Now, and actually it's going to be a parenthesis around, so let me go back. It's going to be a parenthesis around 2 because of the open circle. So this is going to be the domain of the combined function. The domain of the numerator, if you had to do it separately, so the domain of the numerator is just from 0 to infinity. The domain of the denominator is just -2, +2 with brackets. But the domain of the combined function is this down here. It's where it had the overlap. Let's try to do the next one. Now we're going to flip it. So the combined function is 4 minus x squared over the square root of x. All you do is plug it in. And now what we need to do here, again, is find our domain. So this time the numerator, 4 minus x squared, it's greater than or equal to 0. So when I went to go do my check in x's here, it's going to be this. But know that instead it's going to be closed circles for the numerator's domain. So my domain of the numerator is going to be brackets -2 to +2. But then my domain of my denominator is going to be x is greater than 0. So when I go to write my combined domain here, it's going to be from 0 to 2 with a bracket. Because if I put both of them on the number line, -2, +2, and then 0, this was open circle going this way. And then these were closed circles. And again, it's only where the green is. So that's why it had an open circle there. So these are composite functions. And notice the little circle here. This is not a multiplication. So what this means is when you see this, F with the little circle, a G, and then an X, this is read as F composed with G. So what you're going to do is you're going to take the whole G of X function and you're plugging it in for X into the F of X function. And then the bottom one is G is composed with F, where you take the F of X function, plug it into the G of X function for X. So let's try it. So I've got my two functions up at the top. So what this is reading as is F composed with G. So F, and then I'm plugging in the G of X function for X. So I'm going to take my F of X function, and I'm plugging in 4 minus X squared, which is my G of X. And now I'm going to write down my F of X function, which is the X plus 2. So now where I see X here, this is what I'm plugging in. So I'm going to take out X, put 4 minus X squared plus 2, combine my like terms, and I get 6 minus X squared. You can also write it as negative X squared plus 6. Either way. Now we're going to go the other way. Okay, so this one means G, F of X, and then what we're going to do is plug in the F of X function in for X into the G of X function. So remember, my G of X function is the 4 minus X squared. So I'm going to be taking out X, and I'm going to replace it with X plus 2. I got to FOIL this thing. So it's going to become 4 minus X plus 2 squared. So I'm going to FOIL that thing. So remember, X plus 2, X plus 2. Okay, so once I FOIL this, X squared plus 4X plus 4. So here, let me put it in parentheses first. I'm going to distribute the negative sign. I'm now going to combine my like terms. So these cancel out, and then I'm just left with negative X squared minus 4X. Since I've already simplified the G composed with F, I can now use this answer to answer number 11. So I'm going to take number 10's answer, and I'm going to go ahead and replace X with a negative 2. Going to follow order of operations, and then combine, and the final answer is 4. All right, so the next one. Again, we're taking the G of X function, and we're plugging that into the F of X function for the X. So we're taking 4X squared plus 1, and this is what's going to go in for X. So my G of X function is, my F of X function is the 2X plus 5. So I'm taking out this X and putting in there 4X squared plus 1. So 2 times 4X squared plus 1 plus 5. I'm going to distribute. I get 8X squared plus 2 plus 5. Only thing I have to combine is the 2 and the 5. And now let me go ahead and I'm going to go right down below, since that's the same function that we want me to use. So I'm going to take what I just got, the 8X squared plus 7, and now I'm plugging in negative 1/2 for my X. So 8 times negative 1/2 squared plus 7. Negative 1/2 squared is 1/4. 8 times 1/4 is 2, 2 plus 7, and the answer is 9. For number 13, we're taking the f of x function, and it's going to get substituted into the g of x function for the x. So really what we're doing here is taking the g of x function and plugging in 2x plus 5 for x. So my g of x function was the 4x squared plus 1. I'm taking out x and replacing it with 2x plus 5. So 4, and then now put in 2x plus 5. I need to square that, and then I'm going to add 1. So I need to follow PEMDAS. So I need to FOIL 2x plus 5. Once I do that, you end up with 4x squared plus 20x plus 25, and then the plus 1. I have to distribute the 4. 16x squared plus 80x plus 100, and then plus 1. Simplify the 100 and the 1, and I get 101. And I'm done. So to find the domain of a composite function, if you're finding f of the g of x function, you're going to bring down the domain of the g of x. Then you're going to find any additional restrictions from the result of the composite function. So first we have to find the domain of this, and then we're going to do the domain of the composite. So let's go ahead and try an example. So here they want us to take the f of x function, and I'm plugging in the g of x function. So really what I'm doing here is the square root of 9 minus x squared. And again, I'm taking my f of x function, which is x squared minus 9. And remember, you're taking out x and putting this in here. So once I do that, I get 9 minus x squared under the radical. But then remember, it's squared, and then minus 9. Remember, when you square a radical, it just disappears. And then when I combine my like terms, I'm only left with negative x squared. Now remember, the restrictions on this, there are none. This is all real numbers. There's no radical, there's no fraction. So the domain of the composite is all real numbers. However, the original thing that I plugged in, this is what I plugged in. So I also have to check this one's domain. So remember, this is under a radical. So when it's under a square root, you set it greater than or equal to 0. I would add x squared. I get 9 is greater than or equal to x squared. So this becomes plus and minus 3. Remember, when it's quadratic, you got to do the checks. Okay, so I calculated the domain of the combined function, and you already saw that it was going to be all real numbers. Now what we're doing is working on finding the domain of the input function, which was the g of x function. Remember, when you have a quadratic inequality, we have to do the x check and figure out where it is. So if I put a 0 here in between my negative 3 and positive 3, and then if I plug it back into the original, the 9 minus x squared greater than or equal to 0. Once I plug in a 0, I get 9 greater than or equal to 0. This is a true statement. So my check mark is going to go here. So my domain for my input function, my g of x function, is going to be from negative 3 to positive 3. So the domain of this, because I have to also take into consideration my input function, not just the final composite function, the domain of this function is going to be from negative 3 to positive 3. And then the last question, Again, they want us to do exactly the same thing. We're taking the g of x function and we're plugging it into the f of x function. So my g of x function is the x squared plus 4. So then what I'm doing is now composing this, I'm taking my f of x function, which is the square root of x. So I'm going to go ahead and plug in x squared plus 4 and just put it under the radical. Because remember, your f of x function was just the square root of x. So I've taken out x and in its place put x squared plus 4. So this is my composite function. So now to check for my domain, remember your input function, there was no restriction on it. So I just need to check this, and this is x squared plus 4, and it's under a radical, so greater than or equal to 0. As soon as I go to solve this, notice what I'm getting is an imaginary solution. And I don't need to worry about excluding any imaginary values. So my domain here is going to be all real numbers. And that is it for the notes on section 2.2. Sorry, 2.6. And that concludes chapter 2.